Hello, my name's Mrs O'Neill and I work for the Athelston Trust Central team. I'm going to talk you through the November 2019 Foundation Tier Paper 2. You are allowed a calculator for this one. Give the questions a go first, and if you need a little bit of help, press play, listen to a little bit of my answer, and then press pause to see if you can carry on. Once you finish the question, press play and listen to the rest of the answer. If you need some extra help, have a look on Sparks or Corbett Maths to help you. Good luck! These sentences are on every paper right at the start. They say answer all questions, write your answers in the spaces provided, and you must write down all the stages in your working. I'm not sure how many students actually read these 3 lines, but they are really important. Something I would thoroughly recommend is answering all questions. Unless you've written something, there's no way you can pick up any marks. And if you look through your question level analysis from your mocks, it's likely there are quite a few questions where you've picked up 0 marks, not because you got it wrong, but because you actually didn't write anything. Can I please thoroughly recommend that you try and attempt as many questions as you possibly can, writing something, even if you have to go back to them after you've finished the paper. Writing your answers in the spaces provided is really important because the paper gets scanned in for the examiner to mark, and therefore if you write outside of that area, they may miss your bit of working. And finally, writing down all the stages in your working means that you may get credit for your workings even if your final answer is incorrect. So if you type something into your calculator, make sure it's written down on the page as well. If you think something in your head and do a little bit of calculation in your head, write it down on the page as well. The examiner needs to see everything you've done. Now let's start the paper. Question 1. Write these numbers in order of size. Start with the smallest number. So looking across those numbers, I can see that the most negative number, the number furthest below 0, is -7. So I'm going to start with that one. Then we go to -4 as we head back towards 0. -2, you can see I'm putting lines underneath them as I go to show that I've already written them down. Then we get above 0 with 1, and finally 8. Number 2, write the number 8,375 correct to the nearest thousand. So the number we have is 8,375. I've got 8 in the thousands column and 3 in the hundreds column. The 3 means that I'm going to round to 8,000 because the number is closer to 8,000 than it is to 9,000. Number 3, write 0.23 as a percentage. 0.23 is 23%. Question 4, find the value of root 17.64. So we're looking to find the square root of 17.64. On your calculator, if you press the button with the root sign with the box underneath blanked out, and then press 17.64, that will come up on your screen. Press equals, and you should end up with 4.2. For number 5, find the value of 6 to the power of 5. You need to press the button on your calculator that looks like this, X with a little box at the top, once you've pressed the number 6. So press 6 and then X to the power of, and then press 5. You'll end up with 6 to the power of 5 on your calculator, and then press equals, and you will end up with 7,776. Question 6. There are 14 rows of seats in a cinema. There are 15 seats in each row. A film was shown in the cinema on Saturday. Each ticket for the film cost £6.50. The tickets that were sold cost a total of £1,274. How many tickets were not sold? So let's unpick the question. We've got lots of words here. Let's think about what are the key pieces of information. So there are 14 rows of 15 seats. So I can use that information to work out how many seats are in the cinema. I then know that each ticket costs £6.50, so each seat will cost £6.50. And I know the tickets that were sold cost £1,274. So if I can work out the total price of all the tickets, if they were sold, all sold, and take away the cost that they were sold for, that will leave me with an amount that then I can divide by £6.50 to give me the number of seats. So that's going to be my strategy. So the first thing I said, I was going to work out the number of seats in the cinema. So 14 times 15, you've got your calculators, that gives you 210. There are 210 seats in the cinema, and each of those seats can sell for £6.50. Again, you've got your calculators, you'll get £1,365. So that is the maximum number of sales, or the maximum price that the cinema can get in if they sold all the tickets. But they didn't sell all the tickets because they only got in £1,274. So I'm going to subtract that from the £1,365. Again, you've got your calculators and you can get £91. So they were £91 short of selling all the tickets. So £91, each ticket we know costs £6.50. So in your calculators, 91 divided by, you can just do 6.5, and that will leave you with 14. So 14 tickets were not sold. 14 tickets were not sold. Anything you've typed into your calculator, make sure you've written down here, because you'll see it's worth 3 marks. So everything you type, always write too. Question 7. Harry has 20 sweets. He gives 7 of the sweets to Nadia. What fraction of the 20 sweets does Harry have now? So we know that he had 20 sweets and he gives 7 away. So we're going to subtract 7. That leaves Harry with 13 sweets. We're looking for a fraction of 20. So the fraction that Harry still has now is 13 out of 20. Note this is worth 2 marks, so it's worth showing this subtraction. 20 take 7 equals 13, because that will get you a method mark, even if you don't leave the final answer as they would like, 13 over 20. Question 8. Here is a number machine. Input, multiply by 8, subtract 5, output. Part A, work out the output when the input is 6. So if I put 6 in, I times it by 8, and then subtract 5, I get my output. So 6 times 8 is 48, and then take away 5 leaves me with 43. 43, 1 mark. Here is a different number machine. Input, add 13, do something else to it, get your output. When the input is 17, the output is 10. Complete the number machine. So we put 17 in, we add 13 to it, we then do something else to it, and we get the output of 10. So I know that 17 add 13 is 30. I then do something to that, and I get the answer 10. So there's a couple of answers you can put for this. So you could have put take 20, that would get you a mark. You could have put divide by 3, that would get you a mark. Or you could have put times by a third. That would also get you a mark. Question 9. Here is a list of numbers. 6, 4, 8, 9, 4, 3. Work out the median. To work out the median, we need to put the numbers in order. So first of all, the smallest number then is 3, then 4, then 4, then 6, then 8, then 9. That will gain you 1 mark for putting them in order. And then we need to find the middle number. Because there's an even number of numbers, there's actually 2 middle numbers here. So we need to go halfway in between 4 and 6, and that is 5. If the numbers were further apart and it was harder to see what the middle number was, you're actually finding the mean of those 2 middle numbers. So 4 plus 6 divided by 2 gives you 5, and that will always work. So the median is 5. Aisha picks at random one of the numbers. Part B, what is the probability that she picks an odd number? So if we look at that list of numbers, there are 2 odd numbers, 9 and 3, and therefore that's 2 out of 6. We don't need to simplify, it hasn't asked it for it in its simplest form. And the probability, it could be written as a fraction, a decimal or a percentage, but in this case a fraction is definitely the easiest way to write it. Clara has 5 cards. There is a number on each card. 2 of the numbers are hidden. The mode of the 5 numbers is 3. The mean of the 5 numbers is 5. Work out the 2 numbers that are hidden. So the information we've got, we know the mode is 3 and we know the mean is 5. So I've got the numbers 3. I don't know what the next one is, so I'm going to call that X. And we've got 8, 5, and another one I'm going to call that Y. I know the mode is 3, so the most popular number must be 3. So I'm going to put another 3 in there. So I'm going to replace X with 3. And now I've only got one missing number, and I can use the next piece of information. The mean of the 5 numbers is 5. So when I add all those numbers together and divide by 5, because there's 5 numbers, I get 5. So I know that 3 plus 8 plus 5 plus Y divided by 5, because there's 5 numbers, is equal to 5. When I add up 3, 3, 8 and 5, I get 19. So 19 add Y is divided by 5 equals 5. Therefore 19 add Y must equal 25 if I multiply both sides by 5. Therefore Y, 19 add 6 is 25, so Y must be 6. Therefore my 2 numbers are 3 and 6. Question 10. Here is the charge at a car park in Spain. The car park charges 0.024 euros per minute. John parked his car in this car park. John drove into the car park at 10:45. When he drove out of the car park, he had to pay 8.4 euros. At what time did John drive out of the car park? So let's unpick some of this information then. We know that it costs 0.024 euros per minute, so that's important. And the fact that it's per minute helps us a lot. We know that he paid 8.4 euros or 8.40 euros. And we know that he went into the car park at 10:45, and we want to know what time he drove out of the car park. So we've now pulled out the key pieces of information. So let's think about how we can work out how many minutes he was there. So if he paid 8.40 euros or 8.4 euros, then we know that we can work out the number of minutes by using the price per minute. So if we do 8.4 divided by 0.024, that will tell us how many minutes he was in the car park for. When we do that, we get 350. So we know he was in the car park for 350 minutes. Okay, so now we're going to use the piece of information that tells us what time he went in. So he went in at 10:45, and I need to add on 350 minutes. Now 350 minutes I need to convert into hours first of all. So on your calculator you could do 350 divided by 60 minutes. That will tell us how many hours, and that gives you 5.83 on your calculator. Okay, so we've not got whole hours. We know that it's 5 hours. 5 hours is 300 minutes. So 5 hours at 60 minutes per hour is 300 minutes. So we know that he was in there for 5 hours and 50 minutes. 5 hours and 50 minutes. That's how long he was in the car park for. So if I add 5 hours onto here first of all, we end up with 15:45. So 15:45, and then if I add on another 50 minutes, well, 15 minutes will take me up to 1600 hours, and that leaves me with another 35 minutes past 1600 hours, so that's 16:35. So the answer we need to put in here is 16:35. An alternative answer you could have written would be 4:35 p.m. making sure that you put the PM to show that it's in the afternoon. But I think the easiest way is to leave it as 16:35 in the 24-hour clock. 3 marks. Question 11. You can use this graph to change between stones and kilograms. Change 3 stones to kilograms. So I'm going to use the conversion graph to change 3 stones into kilograms. 3 stones is here, so you can see that I've drawn a line in up at 3 to hit the graph and then go across. We can read off the number of kilograms then is 19 kilograms. Part B says change 80 kilograms to stones. So 80 kilograms. Now 80 kilograms, this only goes up to 70. 80 kilograms is somewhere up there. So there's a few ways you can do this. You could, for example, read off at 10 kilograms and down and then times that by 8. I've chosen to use 40 kilograms, so you can see that I've drawn a line in across at 40 to hit the graph and come down. So I think when I do that, it comes down at 6.4. So 6.4 stones. So I know then that 40 kilograms is 6.4 stones. Therefore, 80 kilograms must be twice that. So that's 12.8 stones. So 12.8 stones would be my answer. Now yours may be slightly different. There will be a tolerance in the mark scheme. So yours may be slightly lower than mine, or I think it's 12.4 to 12.8 in the mark scheme as the final answer. And you may have done it a slightly different way, and that's fine. But make sure your answer is about 12.8. Question 12. Find the number that is exactly halfway between 1/10 and 3/5. Now there are lots of different ways that you could do this one. So you have a calculator. The number that we find that is exactly halfway between them is the same as finding the mean, actually. So as I mentioned earlier, when we were finding the median, when we wanted to find halfway between 4 and 6, you can add the two numbers together and halve it. So here in your calculator, you could do 1/10 plus 3/5 and then divide it by 2. That will give you your answer, and the answer is 7/20 when you do it in your calculator. Alternatively, you could convert them into decimals, so 0.1 is the same as 1/10, and 3/5 is the same as 0.6, and then we could divide those by 2, so we end up with 0.7 divided by 2, which is 0.35. That's equivalent to 7/20. So either would work. On my answer line, you could write 7/20 or you could write 0.35. They will get you both marks. Question 13. On the grid, draw an enlargement of the shaded shape with a scale factor of 3. So for this question, you just need to multiply all of the lengths by 3, draw it somewhere else on the grid. So when you do this, you can see that first of all, we've got 2 squares wide here, 2 squares tall here. So that means when we multiply it by 3, a scale factor of 3, it's going to become 6 by 6. And then we need to think about how we put in this diagonal line. Well, I know that to get to this corner here, this vertex, I need to go from this corner 1 across and 3 up. So on the new shape, it instead of being 1 across and 3 up, would be 3 across and 9 up. And then when that shape is joined up, you will end up with an enlargement of a scale factor 3. Question 14. A shop sells compost in 20-litre bags and in 40-litre bags. One day the shop had 2 special offers for the compost. 2 bags for £3.50 for the 20-litre bags. 3 bags for £9 for the 40-litre bags. Which offer is the better value for money? You must show how you get your answer. So let's work out then how much we actually get for our money. So 2 bags of the smaller bags, 2 bags is 20 litres each, gives us 40 litres. So 40 litres of the smaller bags costs us £3.50. Put my pound sign in. Now, for the bigger bag, the 40-litre bag, we get 3 lots of 40 litres. That's 120 litres. And the 120 litres, that will cost us £9. Now, I need to make a comparison here. I know that 40 litres is £3.50 and 120 litres is £9. So I either need to multiply up on the 40 litres to get 120 litres or divide to get 40 litres on the bigger bag. So I'm going to divide this one by 3 and make a comparison this way. So if I divide both by 3, I get 40 litres is £3. So we can see on the smaller bag, the 20 litre bags, we get 40 litres for £3.50. And on the bigger bags, we get 40 litres for £3. So I've shown the examiner clearly how I've come to my conclusion then that the 40 litre bag is better value for money. Question 15. The length of the plane is 19.2 metres. Lucas buys a scale model of the plane. The scale of the model is 1 to 24. Work out the length of the scale model of the plane. Give your answer in centimetres. So let's unpick it. We've got the length of the plane, that's 19.2 metres. We know the scale is 1 to 24, and we need an answer in centimetres for the length of the scale model of the plane. So we know that 1 centimetre on the model is 24 centimetres in real life, or 1 metre on the model is 24 metres in real life. Now we've got 19.2 metres as the actual length of the plane, but it wants our answer in centimetres. So I'm going to convert the 19.2 metres into centimetres. So if I multiply by 100, because it was 100 centimetres in a metre, I get 1,920 centimetres. So I know that 1,920 centimetres is the length of the plane in real life. Now I need to think about how I get from 24 to 1,920. I get there by multiplying by 1,920 over 24, because 24 times 1,920 divided by 24 gets me back to 1,920. So if I do the same on this side, multiply by 1,920 over 24. Now if you put that into your calculator, 1 times 1,920 divided by 24, put that in and you get 80. So 1,920 centimetres in real life is worth 80 centimetres on the scale model. So that is my answer I can put on the answer line, 80 centimetres. Question 16. Maria invests £4,500 in a savings account for 3 years. The account pays simple interest at a rate of 1.8% per year. Work out the total amount of interest Maria gets by the end of the 3 years. So let's unpick what we need to help us work this out. So 4,500, that's how much she invests, and she's putting it in for 3 years. The account pays simple interest. Now that's really important. So it's simple interest as opposed to compound interest at a rate of 1.8% per year. Work out the total amount of interest Maria gets by the end of the 3 years. So the fact that it's simple interest means that we don't need to think about how much she gets in the account at the end of year 1, year 2. We just need to think about how much 1.8% of £4,500 is and times that by 3. So with a calculator, that's relatively simple. So if I do 4,500 multiplied by the decimal equivalent of 1.8%. So 1.8% as a decimal is 0.018. So if I multiply 4,500 by 0.018, I get 81. So £81. That's how much she gets in 1 year as interest. But she invests it for 3 years. So she gets 3 times that amount. So she gets £243 interest over the 3 years. Now this question says work out the total amount of interest Maria gets by the end of the 3 years. So our answer is £243. Always read this carefully. Sometimes it'll ask you how much is in her account at the end of the 3 years, in which case you would also need to include the 4,500. But this one just asks for the total amount of interest. 2 marks. Question 17. ABC is a straight line. AB equals BC equals BD. Angle DAB equals 64 degrees. Work out the size of the angle marked X. Give a reason for each stage of your working. So you can see that this question is worth 4 marks. So the reasons are going to play quite a crucial part of you getting all 4 marks for this. So we know that AB is the same length as DB is the same length as BC. They've told us that information already, which means we've got some isosceles triangles. We can use that information to help us. So the first thing we know then is that we can find this angle and mark it as 64 degrees because the base angles of isosceles triangles are equal. So we could say that angle ADB equals 64 degrees. So we state what we know is true and give a reason for our answer. Base angles of an isosceles triangle are equal. So using that information then, we can work out then angle ABD, this one here, because we know that there are 180 degrees in a triangle. So 180 degrees, take away the 2 lots of 64 degrees in that triangle, leaves us with 52 degrees. And our reason for that is that angles in a triangle sum to 180 degrees. Okay, so we've stated what we know is true and we've given a reason for our answer. So we now know that this angle, ABD, is 52 degrees, and I would mark it on your diagram, it helps you. Now we need to look into the other triangle because that information is going to help us work out angle X. So we know that this angle here is on a straight line with this 52 degrees, and we know that there are 180 degrees on a straight line. So 180, take away the 52, leaves us with 128 degrees. So if we then say that there are 180 degrees on a straight line, or angles on a straight line sum to 180 degrees. Oh, I've missed the A out. Straight, let's put that in if I can. Straight line. Okay, so then if we then think about the 128 degrees being here, we can put that in. And we then know that there are 180 degrees in a triangle. So 180 degrees, take away the 128, leaves us with 52. You'll notice some repetition here. So 52 degrees, and then we can share that 52 degrees between the 2 base angles of that isosceles triangle, leaving us with 26 degrees. So 26 degrees for angle X. So my answer then is 26 degrees, or X equals 26 degrees. I've already given the reasons in my brackets up here for these last 2 lines, so I don't need to repeat them. Question 18. Ben is n years old, Chloe is twice as old as Ben, Dan is 5 years younger than Ben. The total of Ben's age, Chloe's age and Dan's age is t years. Find a formula for t in terms of n. So if we look back again, we've got Ben is n years old. Okay, I can say Ben is n years old. Chloe is twice as old as Ben. So if I take Ben's age and times it by 2, I get Chloe's age. So to write that algebraically, we would write 2n, 2 times Ben's age, or 2n. Dan is 5 years younger than Ben. So if Ben is n years old, then if we do his age, take away 5, we get Dan's age. It then says the total of Ben's age, Chloe's age and Dan's age is t years. So I know t years is equal to Ben's age, which was n, add on Chloe's age, which was 2n, add on Dan's age, which was n take 5. Then to simplify that, I get t equals 4n take 5. And that is actually worth 3 marks. Part B. In the table below, put a tick in the box next to the identity. So an identity looks a bit like an equation. It needs an equals sign, but it will hold true with whatever value we replace the variable with. So if I look down here, the first one I think is an equation. The second one is an expression. I've got no equal sign. The third one is a formula. And in fact, I think you'll recognise that as the formula for the area of a circle. The last one is an inequality. So the penultimate one, 5m take away 3m equals 2m. That is an identity because it will hold true whatever value I replace the m with. So I'm going to put a tick in there. Question 19. Here are the ingredients needed to make 16 biscuits. 175 grams of butter, 75 grams of sugar, and 250 grams of flour. So that makes 16 biscuits with those ingredients, 16. Anna, though, has 500 grams of butter, 300 grams of sugar, and 625 grams of flour. Work out the greatest number of biscuits Anna can make. Now, these ingredients are going to limit me. I suspect one of these will give me my limiting factor. So let's think about how much butter we've got. So Anna's got 500 grams of butter, but for each batch of 16, she needs 175 grams. So that'll tell me how many multiples of 16 I could make using the butter. So 500 divided by 175 on your calculators, if you round it, gives you 2.86. So I could make 2.86 lots of 16 biscuits with that butter. However, I need to check the sugar now. So 300 divided by the 75 grams needed for each batch of 16, and that leaves me with 4. So I could make 4 lots of 16 with the sugar, but actually I'm limited by the butter, so I can't make 4 lots. I'm at the moment limited to 2.86 lots. But I haven't checked the flour yet, so let's do that. So Anna has 625 grams of flour. We'll share that between the 250 grams she needs for each batch of 16. And that gives you 2.5 when you put it into a calculator. So Anna can make 2.5 times 16 biscuits. And that actually is our limiting factor. She doesn't have enough flour to make any more than 2.5 times 16. So 2.5, 2.5 in your calculators times 16. You might not need your calculator. That should give you 40 biscuits. So Anna can make a maximum, the greatest number of biscuits she can make is 40. Question 20. An estimate of the height h meters of a tall building can be found using the formula h equals 4f add 12, where the building is f floors high. A tall building is 110 floors high. The real height of the building is 442 meters. Seb uses the formula to find an estimate of the height of this building. He then finds the difference between his estimate and the real height. Show that this difference is less than 5% of the real height. So let's unpick this question. So if we look, we know that it's an estimate for the height given by this formula here. And we're given that F stands for how many floors high it is, and then the tall building has 110 floors. So we know that F equals 110 in this case. The real height of the building is 442 meters. That's the real height, not the estimate. We're asked to use, or Seb is asked to use the formula to find an estimate of the height. So we know that h, an estimate for the height, is equal to 4 times the number of floors, so 110 in this case, add 12. So if you put that into your calculators, 4 times 110 plus 12, we get h, the height, as 452 meters. That is an estimate for the height. We know the real height then is 442 meters. Show that this difference is less than 5% of the real height. So if we want to find the difference, that means I need to subtract the real height and the estimate. So 452, take away 442, leaves me with 10. So 10 meters is the difference between the estimate, 452 meters, and the real height, 442 meters. And I want to put that 10 out of the real height. So the real height was 442 meters. And then that's a fraction. To convert that into a percentage, then I'm going to multiply by 100. So 10 divided by 442 times 100. If you put that into your calculator and round your answer, you'll get 2.3%. You could round it to 2 decimal places, that would be fine. And then finally, we're saying show that this difference is less than 5% of the real height. So we would say something like the difference is less than 5% as it's 2.3%. And that would get you all 4 marks. Question 21. The table shows some information about the weights of 50 potatoes. Iveta drew this frequency polygon for the information in the table. The frequency polygon is not fully correct. Write down 2 things that are wrong with the frequency polygon. So we need to identify 2 things. There may be more, but we only need to write down 2 things. So there are actually 3 things that I can spot. Firstly, I'm looking at the y-axis and there is no label here. So up here we would need to write something about there being no label on the y-axis. Something else I've spotted is that the polygon, frequency polygon, has been made into a polygon. So we have this first point and last point being joined. So we need to write something about that. So the first point and last point should not be joined. And finally, although we only need 2 things, there is a third thing you could have picked from, and that is looking at this first point again. Hopefully you've look and see and read across that we're not actually at this frequency 6. They have plotted the incorrect first point, plotted first point incorrectly. Double R. It should be at 15.6, whereas it's been plotted at 15.8. Any one of those 3 or a variation on that wording, as you'll see below, will get you the marks. The length of a pencil is 128 millimetres, correct to the nearest millimetre. Complete the error interval for the length of the pencil. So we know this number has been rounded, 128 millimetres. I'm going to put that in the middle of my number line. That's 128 millimetres, not 127 and not 129. So if I go halfway in between those values, I get 127.5 as the minimum it could be, including 127.5, that would round up to 128, and the maximum it could be up to would be 128.5 millimetres, but not including it. That's why you can see on the inequality that they've written on the answer line, it doesn't have the equal sign underneath. So the minimum it could be would be 127.5 millimetres, and the maximum it could be up to, but not including, would be 128.5 millimetres. Tom and Adam have a total of 240 stamps. The ratio of the number of Tom stamps to the number of Adam stamps is 3:7. Tom buys some stamps from Adam. The ratio of the number of Tom stamps to the number of Adam stamps is now 3:5. How many stamps does Tom buy from Adam? You must show all your working. So I know there are 240 stamps to start off with, and they are in the ratio initially Tom to Adam of 3:7. Tom buys some stamps from Adam, and the ratio becomes Tom to Adam 3:5. So initially there were 10 parts. 3 plus 7 equals 10 parts, and so each part would have been worth 240 divided by 10, which is 24. So each part was worth 24 stamps. Tom had 3 of those parts, so 3 times 24, which gives us 72. So originally Tom had 72 stamps. We could go on to work out how many Adam had as well, but we don't need to. Then once he'd bought some stamps, they were in the ratio 3 to 5, so 3 plus 5 gives us 8 parts. So still 240 stamps divided by 8, which is 30. So each part is now worth 30. Tom still had 3 parts, so 3 times 30. So Tom now has 90 stamps. It says, how many stamps does Tom buy from Adam? Well, he had 72 stamps and he's gone up to 90. So 90 take away 72 leaves us with 18. So Tom has bought 18 stamps from Adam. 18 is our answer. Each person in a fitness club is going to get a free gift. Stan is going to order the gifts. Stan takes a sample of 50 people in the fitness club. He asks each person to tell him the gift they would like. The table shows information about his results. 17 people wanted a sports bag, 7 people wanted a gym towel, 11 people wanted headphones, and 15 people wanted the voucher. There are 700 people in the fitness club. Work out how many sports bags Stan should order. So if we look at the sample, we know that there are 17 people out of the 50 that wanted the sports bag. That's 17 out of 50. Now, if there were only 50 people in the fitness club, then it would be obvious, hopefully, that Stan should order 17 sports bags. However, there are 700 people in the fitness club, so we need to scale this up. So if I multiply that by 700, that will tell me how many sports bags he should buy. If you put that into your calculator, you get 238. So 238 is the number of sports bags Stan should buy. Part 2, write down any assumption you made and explain how this could affect your answer. So in this one, you need to write down that it assumes a representative sample, assumes the sample of 50 is representative of all members of the fitness club. Otherwise, if it's not, then the more or less sports bags would need to be ordered. So assumes the sample of 50 is representative of all members of the fitness club in order to make the numbers correct. The number of sports bag ordered correct. Sports bags ordered correct. There's a few different alternatives you could write in there, as you can see above. Here are 6 graphs. Write down the letter of the graph that could have the equation y equals x cubed and y equals 1 over x. Let's take each graph in turn to think about which one could be y equals x cubed. So graph A is a parabola. That's a quadratic graph, so its highest power of x will be 2. It's an x squared graph. B is a cubic graph, but it's not the graph of y equals x cubed because it crosses the x-axis 3 times, whereas for the graph of y equals x cubed, it will only cross once. C is a reciprocal graph. D is also a reciprocal graph. E is a linear graph, and F is a cubic graph, and it only crosses the x-axis once at the origin. 0 cubed is 0, and therefore F is the answer to A. For part B, y equals 1 over x, that's a reciprocal function, so we're looking for a reciprocal graph, and then we need to make sure it's a positive reciprocal graph, so we end up with D as our answer for part B. The nth term of a sequence is 2n squared take 1. The nth term of a different sequence is 40 take away n squared. Show that there is only one number that is in both of these sequences. So I think the best way to do this is to generate some terms of the sequence. I'm going to do that in a methodical way. I'm going to draw out a little table. I'm going to have my nth term of the sequence here, so 2n squared take 1 is the first sequence, and 40 take n squared is the second sequence. And then for the first term, n is 1. For the second term, n is 2. For the third term, n is 3. For the fourth term, n is 4. And for the fifth term, n is 5. So to generate the terms of the sequence, I'm just substituting in 1 for the first term. So 2 times 1 squared, 2 times 1 is 2, take away 1 is 1. 2 times 2 squared is 8, take away 1 is 7. 2 times 3 squared is 18, take away 1 is 17. 2 times 4 squared is 32, take away 1 is 31. 2 times 5 squared is 50, take away 1 is 49. I'm going to stop there and I'm going to do the next sequence. If I need to do some more terms, I will. So 40 take away n squared. So the first one, 40 take away 1 squared is 39. 40 take away 2 squared is 36. 40 take away 3 squared is 31. 40 take away 4 squared is 24. And 40 take away 5 squared is 15. At this point then we can see that we have one number that is the same in the sequence. So 31 is in both sequences. We don't need to carry on because we can see that the first sequence is increasing and the second sequence is decreasing. Therefore, we're not going to have another number that's in both sequences. Work out 3.42 times 10 to the negative 7 divided by 7.5 times 10 to the negative 6. Give your answer in standard form. So when we're looking at this one on a calculator paper, ideally you would type this into your calculator. So if you type in 3.42 and then use the button that says times 10 to the x or exp, press that and then type negative 7 in, then divided by 7.5, use the times 10 to the x button again, and then negative 6, press equals, and you will get the answer 0.0456 come up on your answer screen. Now it does say give your answer in standard form. That's not written in standard form. To be written in standard form, it has to be a number between 1 and 10, including 1 but not including 10, times 10 to the power of something. So I'm going to write it as 4.56, that's a number between 1 and 10, that I can then multiply by 10 to the power of something to get back down to 0.0456. Now, because it's less than 1, I know I'm going to have a negative power. It's moved all the numbers 2 places smaller than I actually have written here. So 4.56 has become 0.0456. So I need to move everything 2 places smaller, and therefore it becomes 4.56 times 10 to the negative 2. If you want to check it, or you're not sure on how to use the times 10 to the x button on your calculator, then you could write it as 3.42 divided by 7.5, do that in your calculator, times 10 to the negative 7 divided by 10 to the negative 6. If you put 3.42 divided by 7.5 into your calculator, you get 0.456, and that's being multiplied by 10 to the minus 1, or 0.1, which is the same as 0.0456. You could use your index laws on here as well. 10 to the negative 7 divided by 10 to the negative 6 is the same as negative 7 take away negative 6, which leaves you with negative 1. So we've got 10 to the negative 1 there. The answer should be 4.56 times 10 to the negative 2, however you get there. The number of days, D, that it will take to build a house is given by D equals 720 divided by N, where N is the number of workers used each day. Ali's company will take 40 days to build the house. Haley's company will take 30 days to build the house. Haley's company will have to use more workers each day than Ali's company. How many more? So the number of workers used each day is represented by N, and the number of days it takes to build the house is represented by D. We know that Ali's company, D, the number of days, is equal to 40, and for Haley's company, the number of days is 30. So if we substitute that into the equation that we've been given, so we get D equals 720 divided by N, so therefore 40 equals 720 divided by N. So 40N equals 720, so N is equal to 720 divided by 40. 720 divided by 40 is 18, so 18 workers for Ali's company. Haley is quicker though, she takes 30 days, her company takes 30 days, so 30 equals 720 divided by N. 30N therefore is equal to 720, and N is equal to 720 divided by 30. So N, the number of workers for Haley's company, is equal to 24. So we now know that Ali's company uses 18 workers, Haley's company uses 24 workers, so 24 take away 18 is 6 workers. Haley's company uses 6 more workers than Ali's company. The diagram shows a cube and a cuboid. The total surface area of the cube is equal to the total surface area of the cuboid. Janet says the volume of the cube is equal to the volume of the cuboid. Is Janet correct? You must show how you get your answer. So we know that the surface area of the cube is equal to the total surface area of the cuboid. They've told us that. We're then checking to see whether Janet's statement about the volume being equal is correct. So let's start with the surface area first of all. So the surface area of the cuboid we can work out by finding the area of those 6 rectangular faces. So I'm going to label them the ends. So we've got 2 ends, we've got 2 sides, and we've got a top and bottom. So the ends, first of all, they're 6 by 8, but there's 2 of them, so I need to times by 2. The sides, they're 6 by 18, but there's 2 of them, so I need to times by 2. And the top and the bottom, well, they are 8 by 18, but there's 2 of them. So if I then work out what they are on my calculator, 6 times 8 times 2 is 96. 6 times 18 times 2 is 216, and 8 times 18 times 2 is 288. Right at the beginning of the paper I said anything you put into your calculator make sure you write out as well. So we've typed in 6 times 8 times 2 into your calculator, make sure you've written it down on your paper as well. I'm going to add those up then to give me the total surface area, which gives me 600 centimetres squared as a surface area. Then I can take the fact that I know that the surface area of the cube is equal to the total surface area of the cuboid. Now I'm going to label the side length of my cube as x. So all the sides are the same because it's a cube, so they're all labelled x. So when I want to find the surface area of this, I've got this square here, but there's 6 of them, they're all the same shape, so the area of one face would be x squared, but I've got 6 of them, so that's 6x squared. And I know, because it tells me in the question, that that must be equal to 600 because it's the same as the surface area of the cuboid. So if 6x squared is equal to 600, if I divide both sides by 6, I get x squared must be equal to 100. Now I need to find the square root of that to find x on its own. So the square root of 100 is x. So x must be equal to 10. It can only be positive because it's a length. So 10 centimetres is the length of x. I'm then going to use that information to help me with the volume. So the volume of the cube then, I find by doing 10 times 10 times 10, or 10 cubed, and that gives me 1,000 centimetres cubed. The volume of the cuboid is going to be 6 times 8 times 18. And if you type that into your calculator, you get 864 centimetres cubed. So I now need to finish the question. It says, is Janet correct? Janet is incorrect. Or Janet is not correct. We can clearly see from our workings the volume of the cube is 1,000 centimetres cubed and the volume of the cuboid is 864 centimetres cubed. Here are two column vectors. A is 5, 2, B is 3, negative 1. On the grid below, draw and label the vector A, take away 2B. So the first thing I'm going to do is try and work out what A take away 2B is as a column vector. I know that A is 5, 2, and I want to take away 2 lots of B, which is 3, negative 1. So I have 5, 2, and I want to take away 2 times 3, which is 6, and 2 times negative 1, which is negative 2. 5 take away 6 gives me negative 1, and 2 take away negative 2 is 2 plus 2, which is 4. I then need to put that as a column vector onto this grid because I now know that A take away 2B is equal to negative 1, 4. Pick a point, go 1 to the left and 4 up, and you'll end up with your vector. Make sure you put an arrow on it to make sure that it's showing the correct direction. It could be anywhere on the grid. As long as it's the same length and parallel to the one I've drawn, yours will be fine. Well done. That's that paper complete. 2 down, 1 to go. If there were any topics that you found a little bit trickier along the way, have a look at Sparks Maths or Corbett Maths to do a bit of revision on them before attempting some other exam questions on those topics. Well done.